Hey y'all, welcome to lesson 5.3. Can be found on these pages. You've got a few new vocabulary terms here that you'll need to know by the end of this lesson, and making sure you're using those extra examples in the book. There's some examples we'll do together here, lots more in the book you can see. So with this lesson, we're going to talk about medians and altitudes of a triangle. In our previous lesson, I'm going to go back to that. I'm going to be referring back to that a little bit here and there. We talked about bisectors. We talked about, instead of medians and altitudes, we talked about perpendicular bisectors, and we talked about angle bisectors. These are the four major ways, major types of centers, different types of centers of a triangle. So let's start off with what a median is in the first place. So we're going to take I'm going to make mine a little thicker here. We're going to make a triangle, just kind of any old triangle will do, but let's make yours look like mine as best as possible so we have something similar to compare with each other. So let's go with something like that. I don't want to fill that, so let me change the properties of that. Want fill, no fill, none. There we go. Okay, you can go away, thank you. And we're going to find the midpoint of this side right here. So take out your ruler, and let me just remind you of that at this point again. You're going to need three things again for this lesson. You're going to need a ruler, you're going to need a compass, and you're going to need a protractor. So if you need to pause the video to go get those things, go do that right now. Get those three things, come back, and when you're ready with that, hit play again. So did I lose it? There we go. I lost. My pen was facing the wrong way. Okay, there we go. And so now I'm going to get my ruler out here, move this around. You could use inches, you can use centimeters, you can use the little mark that says millimeters. I've got mine here. That looks like right about 50 to me. So if I went right at 25, that should be halfway right there. So here's 25. That's right there at 25. That's going to be the midpoint of that side. So I'm going to put a little mark here. I'm going to put a little mark here, and where I've put a little mark right there in the middle, I'm going to, take my line tool, and this will be lightly. So I want you with this lesson to be just like before, drawing the triangle itself in a bit thicker, and then these other lines drawing in a little lighter. So this is the thicker part. This stuff is a little lighter. This part right here, what I just drew, that's called the median. So right here, draw a little arrow there. This is a median of a triangle. And I'm going to try to make this definition as brief, concise as I can. All it all it does is connects a vertex to the opposite midpoint. If I wanted to give a fancier definition, I could say something like this: a segment whose endpoints are a vertex of a triangle and the midpoint of its opposite side. So that's what I've done here. I've connected a vertex. These are the vertices of the triangle, plural, but a vertex is singular. Connects a vertex to the opposite midpoint. So if I wanted to find the median of this side right here, it would be the vertex here to the opposite midpoint. So that would be that median. And the third median, the midpoint, would be right about here, it looks like. I would connect that to there. So just some terminology to start there. And now let's draw in, before I move on though, let's write some stuff here. So this is A, B, C, and D. So in this picture, the median is AD. So it's AD here. Excuse me. So let's draw another triangle in. Draw this a little thicker. I'm going to make this one acute. So try your best to make yours look like mine. I want to make that thicker. So let's undo that. I was ready to go there. There we go. And this time I'm going to leave some room over here to write some stuff off to the left. But again, I try to make an acute triangle make sure it is an acute triangle. And I forgot to change the fill again. Easy to fix, there we go. And you can go away again, thank you. And we're going to find the midpoint of each side here to start. So let's draw on some steps. So just like before, we're going to have some steps that go along with the triangle in question here. So step one. Step one, we do not need any extra space here really, so I'm going to put this kind of up close. Step one is to draw any triangle. This will work with any triangle, but try to make yours look like mine as best you can. So draw any triangle, and we'll call it ABC again. So call it triangle ABC. And I'm going to say this is point A, this one's going to be B, this one's going to be C. Step two. You should be thinking, well, we just did something with medians, so we're going to be drawing in the medians of the triangle and see if they kind of meet in the same place like we saw before with the perpendicular bisectors and angle bisectors. So let's find the midpoints of each side. And then draw the three medians. So I'm going to find the midpoints of each side. I'm going to get my ruler out, line that up there. So it looks like about 72, it looks like to me on this one. So I'm going to go with 36. There's a midpoint for that one. Rotate this around. Find the median of this side. Find the midpoint of this side, I should say. Looks like a little less, maybe like 68 there, so this would be about 34, right about there. And I'll spin this around one more time. So line your ruler up. Yours is going to be different than mine. I can almost guarantee it. Looks pretty good to me right there. And this looks like, oh, I would say this side looks the shortest just by a little bit. I'd say about 64 it's lining up with right here. So I'm going to go 32 right about there. It's 32. So what am I doing now? I'm finding the midpoints of each side. I did that. Then draw the three medians. So I'm connecting each vertex to the opposite midpoint. Do this with white lines, please. So connecting vertex to opposite midpoint. You'll notice these ones are a little bit easier to draw than some of the other ones I'm doing because I don't need to use a compass for this. That makes it a little easier, I think. So we'll connect all those, and you'll notice, hey, they all meet in a similar point, the same point. Another point of concurrency again. So this is step 3. We're going to take that point of concurrency, we're going to label it with a P again. So label the point of concurrency P. And we'll also say this down here. It is called the centroid. Cool name, the centroid of triangle. I don't know why I wrote of so far away. Of triangle A, B, C. So this point right here, let's label that. Let's also label that this and this were the same. This right here and this right here were the same. This right here were the same. You'll notice this is not perpendicular to this. This is not perpendicular. All we did was connect the vertex to the midpoint. So these are not perpendicular bisectors. These are medians this time. And this point right here is called the centroid. And there's one other pretty big thing here we need to know about this. This also, or this always works out this way. Pretty cool that it does that. So this is theorem We had 5.6 and 5, or 5.5 and 5.6 before. This is theorem 5.7. Something cool here that always works out. This larger part of this median always ends up being 2 times bigger than this other part. And I want to label a couple other things here. I'm going to call this, I forgot to label this with a P. I'm going to put a P here, that's that one. And I'm going to say this is D, E, and F over here. This always ends up being true. So we can say that AP, the book writes it a little different with fractions. I think this is a little easier way to think about it. But you can think about it the fraction way too. Whatever way works better for you, whatever way you understand better, go ahead and use that. Look in the book, if you want to check that out in the book. This is on page 279. So the way they write the theorem is a little different than the way I'm writing the theorem, because I think it's easier to not deal with those fractions. So AP is 2 times bigger than DP. If you cut the whole thing into thirds, this is what the book says, that this is 1/3 of the whole thing, and this is 2/3 of the whole thing, which should make sense if it's 2 times bigger than the shorter part. So BP, same sort of thing. BP is 2 times bigger than EP, so 2 times EP. And CP is 2 times bigger than FP. That's the big thing to remember to go along with this one. And let's just make a little note of that over here. The larger part is 2 times bigger. That's what that's saying, basically. So the larger part is 2 times bigger of each segment here, of each median. So the AP is the larger part of this median, AD is the whole median. It's 2 times bigger than this part. This is 1/3 of the whole thing. This is 2/3 of the whole thing. And similar stuff with B, E, and FC or CF. Okay, so let's do an example to check that out a little bit. Let's draw in another triangle. This one I'm going to make acute as well, but I'm going to make something a little bigger here. Go and so I'm going to make this angle a little smaller. I'm going to make this angle a little bigger than I did before. Alright, so that looks good to me. Keep forgetting to unfill. Alright. And let's call this point H up here. Let's call this point J, and let's call this point G. We got to find the midpoint first, so we're just going to go through our steps here, find the midpoints, then draw the medians. We'll label the point of concurrency. So going through our steps, see if you can do this correctly with your measurements. Good to go with yours. So mine looks like about 70 there, so I'm going to go halfway of that is 35. Draw on the midpoint. I'm going to find halfway of this one up here. That looks like, I'd say about 56 to me, from 0 there to the edge. So that's going to be about 28 for me. Yours is going to be different. You got to find halfway of whatever number you've got. And finally, got one more to measure here. Okay, this looks like about 74-ish, I would say. So I would say about 37. Do that for me right there. Okay, so now I'm going to take my line tool. You use a straight edge of some sorts and lightly draw in some lines connecting those things. So vertex to midpoint, vertex to midpoint, vertex to midpoint. And then where they all meet in the same place. If you do this right, where they all meet is called the centroid. So let's draw in that this was true. We had that's the same, we had this is the same, we had the midpoint here, and we had this is the same. So these 3 pairs of segments are all congruent. And then let's give these other points some labels too. So I'm going to say that this is C. I'm going to give this a label of Q. This one's going to be R, and this one's going to be M. down here, just kind of some random letters I've chosen there. So let's say that this is true. C is centroid. I'll spell the. I can do that. C is the centroid of triangle GHJ. And I'm going to also tell you that this is true. And CM equals 8. So let's label that in the picture. This is 8 right there. And we're going to try to do this first. Find HM, and then we're going to try to find HC. We'll do whichever one seems easier to us first. So we got to find both of those things. So HM, HC, which one's easier? I think HC is easier. Thinking of the theorem at least in this way, the bigger part is 2 times bigger than the smaller part. And so I see in this picture, this is the smaller part of median HM. So I would look at that. I'll put SOLN for my solution. We can say by theorem 5.7, we would have this being true. HC is 2 times bigger than MC or CM. So 2 times MC. So we got that right from here. Same idea. DP is half as big as AP. In other words, AP is twice as big as DP. That's the other way to think of it. So let's plug in the numbers here. If you had 2 times 8, that would give you your answer. This is HC equals 16. If you were given the larger part, you could still plug it into this, and you would just have to divide by 2 instead of multiplying by 2. So that makes it real easy. So we can also find HM based on this. HM would just be, now you could use the idea, the fact that this is 1/3 of the whole thing. That's the way the book has it. Or HC is 2/3 of the whole thing, and you could solve it like that. Or if you just know both parts based on what we did here, we could say that HM is HC plus MC. And I know that HC is given to me, MC was given to me. CM is the same thing as MC. I would have this is plus 8. I have this part. I just figured out it was 16. So that means HM. Hopefully that's clear that would be 24. And so if you look at the way the book has it, it says this is 1/3 of the whole thing, which is true. 8 is 1/3 of 24. It says this is 2/3 of the whole thing. So 16, that's true. 16 is 2/3 of the whole thing, 24. Let's say we assume one more thing is true. So let's say if QJ equals 21, so we're going to still go with this same picture. If QJ equals 21, let's say I asked you to find QC and CJ. So the whole thing from here to here is 21. So let's call this part, I'm just going to leave this as QC and I'm going to leave this as CJ. But let's look at the book now. So the book writes it in a slightly different way. It tells you, and we've already said this a few times, that the shorter part is 1/3 of the whole thing and the longer part is 2/3 of the whole thing. So here I'm given the whole thing. This is a little bit different than what I had here. Same idea though, so I can kind of check my answer in the same way at the end. This whole thing is 21. The shorter part is 1/3 of that. So I'm going to say that QC equals 1/3 times the whole thing, QJ. And so this right here, this comes from, this is still theorem 5.7, but I'll say this is the book version. So let's write that down here. So off to the side, this is theorem 5.7, the book version. It says the same thing, just kind of in a different way. So 1/3 times that. If you're given the whole thing, this is easier to use. So what's 1/3 times the whole thing? 1/3 times 21. 1/3 is times 21 is the same as 21 divided by 3. You can make this a fraction, multiply it through, you would get QC equals 7. Once I know QC, then I could say it's just going to be 7 times 2. I could go back to what I was saying here, or you could say that CJ, so I could say CJ, I should say, is 2 times bigger than QC, or I could say CJ is 2/3 of the whole thing. This is another way to think about it. So this is again from 5.7, the book version, that I'll make a little line over here, have you do the same thing there. So this is 2/3 times QJ times the whole thing. Again, you could also think of this as it's 2 times QC. That's another way to get the answer for this one. So this is 2/3 times OJ was 20, or QJ was 21, and so I could make this a fraction, could put it over 1. This one I think would be a little more helpful to do that with. This is going to equal, if you don't want to cross cancel first, you can just multiply straight across. It would be 42 over 3, which equals 14. If you cross canceled, you get a 7 here and a 1 here. And 2 times 7 is 14 over 1, which is 14. So QC is 14. So based on that, check our answers. Does this one and this one, are they related in the way that I assumed they would be, or that they should be? Is this one twice as big, in other words, as this one? Yes, it is. So the bigger part, the CJ, I put QC. Boy, good thing I'm checking that. CJ here. This is CJ, not what I had before there. So CJ is the bigger part here. Is that twice as big as QC? You bet it is. So 14 is twice as big as 7. So let's move on from here, and let's now talk about the last one. So far we've got perpendicular bisectors. Let's rattle these off. So far we got perpendicular bisectors is 1, angle bisectors is 2, the medians is 3, the fourth one, the final one, the different types of centers, is altitudes. So altitudes, before I get into altitudes though, I just remembered I wanted to show you one cool thing about centroids. So right here I have, let's see if you can see that. You see that? So that's the centroid right here. I made this triangle, and if I put my finger right in there, sweet, I'll only get one shot at this. So if I put my finger right there, it will balance right on the centroid. So the centroid is, it's kind of cool, it's the balancing point of the triangle. Alright, but let's move on to now our last one, the altitude of a triangle. Altitude of a triangle. What it is, it's kind of like the height of a triangle in a sense. It is the perpendicular segment from a vertex to an opposite side or sometimes it won't actually touch the opposite side, depends on how the triangle looks. So I would say, or line that contains the opposite side. If that last part doesn't make much sense to you, don't worry, I think it will in just a couple minutes here. So a line that contains the opposite side. So over here we're going to have 3 versions. In this first column I'm going to put an acute triangle. This next one I'm going to put a right triangle, and in the final one I'm going to draw an obtuse triangle. So let's get out our straight edge. Let's draw some nice triangles here. Make this first one look acute, and let's make that a little thicker to start. So an acute triangle, all the angles have to be less than 90. Okay, and I just keep making the same mistakes over and over again. I'm supposed to learn from my mistakes. It's not happening. Let's see if I can learn. There we go. So don't fill that in. It's there. That's good. And now let's make a right triangle. So I'm going to go straight down, go straight across. That'll be a 90-degree angle. That looks good to me right there. And make an obtuse triangle. So this one, I'm going to exaggerate this, or just make that really obtuse by doing a triangle kind of like that. Okay, so we've got 3 different triangles: acute, right, and obtuse. Draw those 3 in for me, and then take out your protractor. We need to measure some angles here. So take out your protractor, and let's line this up. We need to find, now this time it's not the midpoint, this is an altitude, so it's perpendicular segment from a vertex. Okay, let's line it up. Let's go with the acute one first. So perpendicular segment from a vertex to the opposite side. So here's the vertex. I got it lined up with that. This has to be lined up in a perpendicular fashion though. So that has to be right on 90. It has to be lined up just like that. So if I draw a line in here now, let's do a light line. Well, mine will be less thick. If I draw that in, that right there is an altitude for the triangle. Notice, does it touch, or does it meet at the midpoint? Usually it doesn't. So this one, it might if it was a special type of triangle, but usually it does not meet right at the midpoint. So I'm going to put a little box here in the corner. This is true, but you'll notice I am not putting in marks here and here, because that's not true. This is just the perpendicular part. So from the vertex to the opposite side, or line that contains the opposite side. Here it touched the opposite side, so I didn't need to do the line containing the opposite side part. So I still need to line this up with the other vertices, so I'm going to line it up with that there. Need to rotate this a little bit more so that it lines up with the 90 there. So let's see just a little bit more there. Say that looks pretty good. Okay, and that's lined up with the vertex, so I'm going to draw my vertex to my opposite side. There we go. So that is my altitude for this side. Drawing the 90-degree mark here. I still have to do the altitude for this, the vertex to the opposite side here. So take your protractor, line it up. Pause if you need to. If you need a little more time than what I'm giving you here, please pause and go back, rewind stuff. Don't. That's the whole. One of the big points, one of the major points, one of the major pros of doing the lesson this way, where you can stop and rewind and have me re-explain things. So make sure you're doing that if you need to. So that right there is the other vertex. I feel like that just needed to be in the corner just a little bit better. So let me just redo that one. Good to go there. So that, no, still not quite where I want it. Okay, now that is definitely pretty darn close right there. So let's call this point P. Is going to be my point of concurrency again. So here, this has a new fancy name as well. So we had fancy names. The center names so far was the circumcenter. That was with this circumscribed idea of perpendicular bisectors. We had the incenter that dealt with inscribed circles, which had angled bisectors going with that. And then in 5.3 here, we've had so far the medians. That was the centroid was a special name of the point of concurrency there. And this one, the final special name we have is the orthocenter. Where they came up with that name, I'm not exactly sure. So the orthocenter P. Here it is, you'll notice it's inside the triangle. So we're going to write that down. It's inside the triangle. And I meant to do something here that we didn't do yet. I actually meant to draw these in a different color. So if you have a different color, great. If you don't, go get one. So if you need to go get a different color, do that. I'm going to change the colors of these If you did this lightly in pencil like I had already told you to do, this should be easy to do, just to take your different color and kind of draw over that. So draw on top of that, because I want this to stand out a little bit more. So let's change the color of these things. I want to add the 90-degree mark in here though too. Okay, and I'm going to just grab each one of these, change the color of all those, and I'll just do that here. Won't waste our time doing that. I'll just do that while I pause. That's more like it. So with your different color, draw in, or just draw over the lines you just drew in there with a different color, and put the 90-degree marks in a different color too. The Orthocenter here, same place, nothing changed. I just changed the color of those. So let's do the same thing over here using a different color. And let's see, I'll get that ready to go there. I'm going to be using my orange now instead. And so doing the altitudes here for this side. Let's start with this vertex and make the altitude to this side. So I'm going to rotate this around, take your protractor, do the same sort of thing. We need to line this right up with 90. So right now it's not lined up with 90, it's more like lined up with like 84-ish, something like that on that side. So I need to line it up. There we go. So it's lined up with the 90-degree mark. It's not lined up quite right with the vertex yet, so there we go for that. And just move that up just a little bit, and looks like we're good to go now. So drawing this in my different color, connecting the vertex to the opposite side. So here's the vertex going to the opposite side in a perpendicular fashion. So right here is the way I have this. Since it's lined up right with 90, I know that's exactly right. So that's got to be 90 right there. Now we're going to take this vertex and go 90 degrees with this side. And so let's line that up here. You might look at this and you say, well, wait a second, isn't it already lined up with 90 degrees? If you say that, you're exactly right. This is already good to go. So this now here, this extends here to 90. This is already lined up with 90. So if you connect the vertex with the opposite side in a right triangle, that's already good to go. That's already at 90. Same thing with this one. If I were to draw this at 90, you could spin this around just to make the point a little stronger here. If I spin that around, you notice this lines up right with 90. If I draw that in, opposite vertex to this side, so on top of this basically, draw in a color here, draw in a color here. These are all the altitudes. So where does the Orthocenter end up? Where do all these altitudes meet? They all meet right here, right at the vertex right there. So this point is what I would call P in this case. So where does the Orthocenter end up? If you have a right triangle, the Orthocenter is on the triangle. And let's just keep it consistent the way I had it before. Orthocenter P is on the triangle. And over here, what do you got going on over here? So same thing. Vertex, find each vertex, connect it with the opposite side at a 90-degree angle. So I'm going to line this up with that side at 90. Oh, almost had it. There we go. Just need to move it. So that's lined up with 90, and now that's lined up with the opposite vertex. So I just need to connect that to that. I'll use my straight line tool. I'll use an orange color for that again. And so I'm going to take this and connect it there. Okay, so I've got, that's 90 degrees. Now if I'm connecting this vertex to the opposite side at 90 degrees, let's see what happens with that. So I need to line this up with 90. And there's a rotating guy right there. And so I need to, that's interesting. I gotta connect this with that. Here's where this comes into play. So this side, it does not touch the altitude actually. So I'm gonna take this, I'm gonna draw in my altitude going to right there, and then in pencil we're going to extend this side out with a hidden line. So I'm going to find my hidden line tool second. Okay, I think I got it. So I'm going to connect this here. I want to make that a little skinnier though. I'm going to connect this here with this. So this continues. This is a straight line all the way from here, just continuing it straight that way. And I'm going to be doing the same thing with that one. I'm going to be doing the same thing here. I'm going to continue this out, straight line. That looks really good to me right there. So this is a straight line here, but this is the actual triangle. So this, we're drawing dashed and we're drawing it really lightly from there to there. This would continue, this orange line would continue this way. So it does stop right here at the line containing the side, but it would continue out this way. So it looks like I'm going to be kind of crossing over there. That's okay. Into that range there. So this will come here. This would continue going up this way. If I continue that perfectly straight, it's going to be right there. And then I still need to do that other vertex, so I need to line this up with the 90. I'll line this up with that line extended, and then line it up with the vertex. So there it's lined up with the vertex, and you'll notice if I draw a line going from here up this way, they're all going to cross at the same point again. So they still have that point of concurrency. We still call that the orthocenter. So this here is going to go to there. I'll draw on the 90 right there and right there, and then from there it becomes a hidden line. So this would continue up this way. I'm going to carry it through or cross it through there. So where is the orthocenter in this case? It's right up here. So this point right here, hopefully you still got a 2 so you can still read that. That's a P right there in that case, and close this. So here the orthocenter P is outside the triangle. And let's draw one more thing in there. It looks like I left one thing out that I wanted to include. This was the altitude because that was perpendicular to that side right here. But if you continue that out, they're going to meet out there. So let's make one final note down here, and I'll have you write this in your different color too. So each solid colored segment you may have done yours in red or blue or something like that. That's fine. But some sort of different color, not pencil, not black. Each solid colored segment represents an altitude of the triangle. So here's one altitude, here's another, here's a third. Over here you've got 1, 2, and 3. The altitudes over here are actually just from here to here, not from here all the way to here. So it doesn't include the hidden part line. That's why I underlined solid and colored. So from here to here is one altitude, from there to there is one altitude, and from here to here is the third altitude. And then let's just wrap this up with a recap of lessons 5.2 and 5.3. So this is really important that we know the difference between all these different types of things we've been learning in the last couple lessons. So in this first column we're going to put the segment type. Write that in for me. In this second column will be the points of concurrency. And this third column will be the points of concurrency's location. And give yourself at least give yourself 3 lines for each one of these. So 1, 2, 3 blue lines for you will do what you need here on this part. We started off with perpendicular bisectors, so that will come first. Perpendicular bisectors. The point of concurrency with that was called the circumcenter. We could draw a circumscribed circle with that. It was called the circumcenter. And then this one had 3 different variations. We had right here, if it was acute, it was inside. Right was right on the triangle, and then obtuse was outside the triangle. So for this, let's write that down. Acute was inside the triangle, and right was on the triangle. Obtuse was outside the triangle. The next one we did was angle bisectors. Write that down right there. Angle bisectors dealt with the in-center. You could draw an inscribed circle. So here's our angle bisectors. Right here and here, angles are the same. Come to that point of concurrency called the in-center right there. And so this in-center was always, with in-centers, they're always inside the triangle. Always inside. Medians was the next one. When you think medians of triangles, you should think midpoints. So I'm going to write that in parentheses underneath that. So think midpoints when you think medians. You're going to connect the midpoints to the opposite vertices. That was a centroid. And centroids were also always inside the triangle, just like in center. So always inside the triangle. And the last one we just did back here was the altitude. So the altitudes, if it's acute, it's inside. If it's right, it's right on it. If it's obtuse, it's outside, just like it was with perpendicular bisectors. So let's write down altitudes. You may hear another word for altitudes as heights. So the heights of the triangles, these are always perpendicular to that. This is the orthocenter. This table, keeping everything straight. Hopefully it allows you to quickly determine what's what. So acute was inside the triangle, just like perpendicular bisectors. Same thing here. Right was on the triangle, and obtuse was outside the triangle. And then I've come up with, I think, what is a pretty clever way to remember this. I'm going to underline the first letters in my different color. Let me stick with the orange I've been using all along. You stick with whatever color you've been using all along. Or I guess you could, if you wanted to get fancy, you could use a brand new color. But I'm going to underline each first letter of those and tell you my secret phrase to help me remember this. I think this is not going to show up very well in the gray part if I write it in orange. Yeah, not real good. So I'll do that in red instead. So just because it's not going to show up real well, I'll use a different color for that. But you can still use your same color you've been using all along, but put this in a different color other than pencil though. So my fancy little phrase here is this, to help you remember what goes with what for your test, especially when you aren't going to be given the opportunity to use your notes to help you out with that. So peanut butter, I like peanut butter a lot, and especially when I'm hiking, peanut butter helps sustain me. Can always be in my cookies and Oreos. And you might say, what the heck are you talking about, Mr. Wagner? Look right here. Peanut butter can always be in my cookies and Oreos. They go in that order. That helps me remember peanut butter goes with perpendicular bisectors, can with circumcenter. So peanut butter can, perpendicular bisectors, circumcenter. Always be in angle bisectors, in center. My cookies, medians and centroids, and Oreos, altitudes, and orthocenter. So let's write this off to the side. That is I think a big time hit, a good hint, good mnemonic device to help you remember what's what here. So hopefully you find this a helpful way to remember what all these things are. This is a great review, recap of what we've been doing these last couple of lessons. And make sure you had all this stuff drawn different colors where I had said to, and nicely, neatly with the rulers and protractors. I guess we didn't end up needing a compass this lesson. I told you to get it, but you didn't end up needing it in this lesson. But that's okay. You still should have it with you at home. Yeah, hopefully you found that helpful. Hopefully you had some fun with the drawings and made some really nice drawings. We will practice these a little bit more in class together. And let me know if you have any questions in class. Have a good one, everybody.